Okay, real quick, if I were you, I would put another little line in here, right here. Okay, because then the parallelograms are all on the one side. All right, are you ready? It's lots of details and lots of drawing right here, so stick with me, and if I'm going too fast, tell me to slow down. Quadrilaterals. Everything we talked about was a well, that's not true. We talked about pentagons for a little bit and octagons and all that, but most of what we talked about was a quadrilateral, which is just a four-sided figure, a four-sided polygon, okay? What made something more specifically a parallelogram? Two pairs of parallel sides. Two pairs of parallel sides, okay, made a parallelogram. Now, if you recall, we learned a lot of different theorems with just a general parallelogram. So I'm going to list those down here as best I can. If we run out of room, we can move elsewhere. Tell me something you know about a parallelogram.
Some have 490 degrees.
That would be more specific. Just a general parallelogram. That'd be a rectangle, right? But just the general parallelogram. They will add up to 360, sure. You could say, always going to add up to 360 degrees. What else? What do you know about their angles? Opposite sides and opposite angles are congruent, right? So if I'm looking at a parallelogram, I'm saying these are congruent, those are congruent, opposite sides are congruent. Okay, opposite sides and opposite angles are congruent in a parallelogram. What about consecutive angles?
They're supplementary.
They're supplementary. Consecutive angles will add up to 180, right? They're supplementary. And then what about diagonals of a parallelogram?
Always equal 90 degrees.
That would be in a more specific type of parallelogram. That's not every parallelogram. What about the length? The length of the diagonals. The diagonals do what? They bisect each other. Okay, meaning if we take a look at this picture here, if I draw my diagonals in, right, it's that these two will be the same and these two will be the same. Kind of hard to see there. Let's do this. Okay, so lots of information about parallelograms. Did I miss anything? Okay, so then the whole left side here is a parallelogram. So everything that we just said is true for the rectangle, the rhombus, and the square. Okay, we're not going to mark all that. We're just going to mark the new things now. So if I look at a rectangle is a parallelogram with four what angles? Right angles. Okay, a parallelogram with four right angles. So if I draw a rectangle, you don't need to tell me any of the parallelogram things. We already said those are all true. So everything up above is true of this. But what was the theorem that went along with parallelograms? With rectangles. What?
Opposite sides and opposite angles are congruent.
That's true because of the parallelogram, right? So you don't need to restate that. What's the theorem?
If one of the angles is right, all the angles are right?
Yes, that is true. There was a theorem that we learned about rectangles. Diagonals are congruent. So if I draw my diagonals in a parallelogram, diagonals bisect. In a rectangle, they are congruent, but still bisecting, right? So that means all four of these are the same length. Okay, so let's think about what that does for our figure. You have two sets of what kind of triangle? Isosceles. So that means all four of these are the same. And it means all four of these are the same. Okay, you also have vertical angles, which I'm not going to mark because it gets real hairy when we start marking all of those little details. But you do have vertical angles. So like these two are the same and those two are the same, right? So that's a rectangle.
Whoa.
Lots going on.
Yeah.
What makes something a rhombus?
Four congruent sides.
Four congruent sides. Oops. Where's my sizing? Okay, so a rhombus might look something like this with four congruent sides. We learned two theorems about rhombuses. Can anyone tell me one of the two? Opposite angles are bisected by our diagonals. That was one of them. So if I draw my diagonals in, diagonal here, diagonal here. Oh, did I say? Yes, opposite angles are bisected. So that means all four of these angles have to be the same. Okay, but it also means all four of these angles have to be the same. There was one other theorem with rhombuses. Perpendicular. The diagonals are perpendicular, right? So that means that 90, 90, 90, and 90. Okay, that's a rhombus. And that's probably the one with the rhombus that gets overlooked the most, is just remember your diagonals are 90. So like if you're looking at a question and you're like, ooh, I can't figure out how to find the missing thing. Are your diagonals perpendicular? Look for that because that gets overlooked quite easily. Okay, so then we have the square. That is four congruent sides and four right angles. And I'm not even going to draw all the things because all the things are already drawn for you. Right here and right here and right here. Okay, so a square is all of those things put together. Any questions on the parallelograms?
Nope. So are you saying that a square, like a square doesn't have to always look like a square?
A square does always have to look like a square. It's just all the properties will be true from every other figure. So all the properties of a rhombus are true of a square, and all the properties of a rectangle are true in a square.
Got it, okay.
But yes, it will always look like a square if it's a square. Okay, so this is the non-parallelogram side. These are not parallelograms. So a trapezoid, there's not a lot to a trapezoid. It has exactly one pair of what? Parallel sides. Or lines would be fine. So a trapezoid could look something like this, right? One pair of parallels. The one thing that is true here that is sometimes overlooked is what is true of these two angles.
They're add up to 180.
They add up to 180. Same thing here. These ones will add up to 180 because you have parallel lines, right? They're same side interior angles. So just keep in mind, you always have SSIA. That is not true of every angle, right? These two don't add up to 180. But the two that are connected to the two parallel lines will add up to 180. Okay, so then if we get an isosceles trapezoid, still has exactly one pair of parallel sides. And it has one pair of what? Isosceles trapezoid. congruent sides, right? It's actually gonna have two pairs of congruent angles. So in an isosceles trapezoid, your base angles will be congruent. So those will be the same. And those will be the same. Do you remember anything about the diagonals of an isosceles trapezoid? They don't bisect.
The line equals 180 or something.
So when you draw in the two diagonals, you will get 180 in the middle if you look at a straight line, a linear pair. What's true of the diagonal of the one and the diagonal of the other?
Yeah, tops are congruent.
They're congruent, right? The diagonals themselves are congruent, which means that this piece is congruent to this piece and this piece congruent to that piece. Okay, so you do have a lot of angles that match up here. For instance, I can say that this angle equals this angle equals this angle equals that angle, right? So you have isosceles triangles with identical angles on the top and the bottom. You see that? Yeah, we'll leave it at that. Good there? Mm-hmm.
Thank you.
You're welcome.
So are the arrows that are like this way, are they just a simple sign for that they're congruent or parallel?
The arrows mean parallel.
Oh, okay.
These mean congruent, the marks on the sides.
Okay.
Can I move on? Okay. The last one is the kite, and that is a quadrilateral with two pairs of consecutive sides, so sides next to each other that are what?
Parallel?
Congruent. There won't be any parallels here. But two pairs of consecutive sides that are congruent, but no opposite sides can be congruent. Okay, so if I draw a kite, in this kite right now, if these are my congruent sides and these are my congruent sides, are there any congruent angles? Which ones?
The ones with the lines on them?
Angles, not sides. There's congruent sides. The left and the right, or the top and the bottom? Left and right. So right now, as you see it, these angles are the same, right? But if we draw our diagonals in, then things change a little bit, right? Now it's perpendicular, so 90 degrees in the middle. But it also bisects the ones that weren't congruent, right? So this angle right here is the same as that one. This one is the same as that one. And then the ones, so like this angle here is going to be the same as this one. And these two. So lots of congruent angles, lots of congruent triangles in a kite. Questions on that? Mm-hmm. Okay. Then we're going to do some problems. So there are, I forget, 12 problems here? Nope, 9 problems here. So just kind of a little bit of the majority of what we've done, okay? These first 3, I don't give you formulas on the test, so you're going to need to know them. These are good ones to write on your cheat sheet for the final exam. But you do need to know these. So remember I said words matter? Were you going to give me an answer or you have a question?
I was going to try to solve.
Okay, so an interior angle sum. So these are your 2 keywords here. What formula are you going to use, Nick?
12 minus 2 times 360.
Oh,
180.
180. So here's the formula, right? N minus 2 times 180. So if this is a 12 gon, then you're going to plug in 12 minus 2 times 180. What do you get? 1800. 10 times 180, yeah. So 1,800 degrees is the sum. That's the total, right? Add them all together, you get 1,800 degrees. What's the difference then if they say find the measure of one interior angle? Technically, this should say of a regular 36 gon.
You divide by 12.
You divide, right? Not by 12, by
36.
36. 12 if we were doing the last problem, right? So interior angle still, so that's n minus 2 times 180. Right, so we're going to go 36 minus 2 times 180, and we're going to divide by what? 36. Can we tell me what that comes out to? I want to say it was like 170. I'm going to plug that in and verify that for me. 34 times 180 divided by 36. Do none of you have calculators out right now?
Okay.
170.
Thank you. 170 degrees. Okay, number 3, similar. Again, this should say of a regular 24 gon. So this says find the measure of one exterior. What do you remember about the exterior angles?
They equal 130, 360.
They will always add up, exteriors will always add up to 360. So if it is a regular 24 gon, what do we do with that 360? Divide by the number of sides. So you're going to go 360 divided by 24. I don't remember what that is either. Anyone do that one? 120. Is it 15? That sounds right. So one exterior angle of a regular 24 gon would be 15 degrees. Okay, so just remember exterior should make you think 360. Interior should make you think 180. Okay, n minus 2 times 180. Okay, yeah.
Where is it? Time for the that they're gonna ask for all size matches.
Just the sum of the exteriors? No, I mean, you should know it's 360, but I don't, right? 360 would be the sum. Okay, number 4. This is a kite. Tell me, can't make my pen a good size here. What's the measure of angle 1? It's not 63.
72.
It's 72. Yeah, this angle here is the same as this one here. So angle 1 is 72 degrees. Can anyone tell me angle 2? 90. Good. Angle 2 should be 90 degrees because the diagonals of a kite are perpendicular. So those are all 90. How do you find angle 3?
You add up 90 plus 72, and which you get 18 if you subtract that from 80.
Right. So 90 and 72 and the measure of angle 3 makes a triangle, which would equal 180 then. So take this away, minus 162. So the measure of angle 3 is 18 degrees. So that's this one. It's also this one. Not that they asked you for that, but that one is getting bisected.
It's 27 for number 4.
So same idea for number 4. If you look at this triangle, right, in that triangle, you have angle 4, the 63, and the 90. So it's going to be 90 plus 63 plus the measure of angle 4. That has to equal 180. So take away the 153, and you get the measure of angle 4 is 27. Okay, lots of triangles, right? Look for triangles. Triangles always add up to 180. Doing okay?
Mhm.
All right, number 5 says this figure is a rhombus. Find the measure of the missing angle. So the angle that they're giving us here is UST. That's this angle. How do we get there? Yeah.
You can tell that all of them are 90-degree angles.
All of what?
All of the corners, like in the middle.
In the middle, right? The diagonals are perpendicular, so we know these are all 90.
And then from there, we can do 90 plus 28 minus 180 to get our angle.
Right, so in a rhombus, all 4 of these will be the same. And all 4 of these will be the same. Right, so if that's my setup and we're looking for, we'll call it X. This angle, okay, X. This is 28, this is 90. So you're gonna say 90 plus 28 plus X makes a triangle. So take away 118 and you get that angle is, nope, 62 degrees. So this is 118. Any questions on that? Okay, you try number 6 on your own. It says the lines are parallel.
Can we go back?
And we want the perimeter of ANMK. So ANMK is this figure, right? ANMK. So it's a quadrilateral. We want the perimeter. See if you can figure that one out. What'd you get?
37.
37. What is NM over here?
5.
It's 5, right? If these are parallel, which they tell us they are, and these are equal, then these have to be equal also. So you're doing 13 and 5 and 16 and one of those 3. So 3 plus 13 plus 5 plus 16, which I believe is 37, would be your perimeter. Good on that? Okay. This one says it's a trapezoid, and V and S are mid-segments. So that means, sorry, midpoints. That means it's a mid-segment. So it says QR is 12. UT is 22. What is VS? So we'll call that X.
17.
What do you do? How'd you find it?
You added 12 and 22, and divided by.
Right. X is going to equal half of 12 plus 22, right? Add the 2 bases together and then cut it in half. So half of 34. So X comes out to 17. Do you know how you can check that?
You just add it in.
If you put a 17 right here, the distance between these 2 is how many units?
3.
5. The distance between these 2 is 5 units. If that number comes out to the same thing, then you know you have the right answer. Okay? It's essentially finding a midpoint. All right, number 8 says, decide if the statement is true or false. If it's false, draw a counterexample. This says the diagonals of a trapezoid must bisect each other. Do they?
No.
This is false, right? If you draw a trapezoid, and it doesn't say isosceles, it's just any trapezoid. So I'm going to draw a dramatic trapezoid here. If I draw a diagonal here and a diagonal here, you can tell that this is not the same length as that, right? Those are very different lengths. So that means they do not bisect each other. Okay, last one. Guys, this is the one that gets done wrong a lot. Ava, what's up?
If they would have said isosceles, then they would be.
Isosceles doesn't bisect either. Isosceles gives you congruent pieces. But that's the same as that, and this is the same as that, but it does not cut the diagonal itself into equal parts, right? It's not that these two are the same. Those two are not the same. So an isosceles has congruent diagonals. The whole thing is congruent to the whole thing, but the parts are not congruent, other than like the top two pieces and those bottom two pieces. Yeah. Okay, this one gets done wrong a lot. This is a parallelogram, okay? So in a parallelogram, if they tell you DM is 7x minus 3, MB is 2x plus 7, AM is 3x plus 4, and MC is 2y. Okay, they give you all this information in a parallelogram. What is true?
That 7x minus 3 equals 2x plus 7.
Right, and can I just tell you what a lot of you are going to be tempted to do? A lot of people on this problem tell me this equals that. What shape would this have to be for that to be true? A rectangle. This is not a rectangle, okay? So please don't set those parts equal. They get bisected. So that means 7x minus 3 equals 2x plus 7. So then we can solve for x. Add the 3. So 5x equals 10. And then divide by 5. So x will be 2. How do you find y?
You substitute the 2.
Substitute. That's going to go in here. And now these two are equal. So we're going to say 3 times 2 plus 4 should equal that 2y. So 6 plus 4 is 10 equals 2y. Divide by 2. So y should be 5. Okay, and you can plug those back in and check your values. They should be the same here and there.
Can I use the next one?
Can I see number 3?
Yes. Any other questions on any of that? It's a lot of properties, right? There's a lot going on in chapter 6, but I also feel like you've done a lot with them. So hopefully they come quickly to you. Ava.
So you plugged that one into the 3x plus 4. Could you have plugged it into any of them?
You can plug it into any of them, but not to set it equal to 2y, right? 2y is only equal to the 3x plus 4. The other two are equal to each other. So if I plugged the 2 in, 7 times 2 is 14, minus 3 is 11. 2 times 2 is 4 plus 7 is 11. Like that's how you could check your answer to plug it in that way. But you cannot say that this equals this or that this equals that because they're different pieces. Yeah, 3 exterior angles always have a sum of 360. So whenever you see exterior angles, first of all, you had to write that it was a regular. I added that in. A regular 24gon means all of your exterior angles will be the same. So then 360 divided by the number of angles will get you that exterior angle. So 360 divided by 24 gets you 15 degrees.
Look at you.
Okay. Okay, your homework is in the bookwork. It's just a chapter review just to make sure we've got it all. I have not gotten a PDF for it, so if one of you wants to send me a PDF, great. Otherwise, you'll just have to do it on your own.
What's the cost?